Problem 43 from chapter 26. How long does it take electrons to get from a car battery to the starting motor? Assume the current is 285 ampere and the electron travels through the copper wire with the cross-sectional area 0.17 centimeter square and the length of the wire is 0.43 meter. The number of charge carriers per unit volume is 8.49 multiplied 10 power 28 per cubic meter. So in this question, we are going to calculate the time taken by the electron to travel. So for this, they gave the information about the current, which is 285 ampere, and the number of charge carrier is given as 8.49 multiplied 10 power 28. And also they gave the information about the cross-section area of the copper wire as 0.17 centimeter square, but we have to convert in terms of meter square. And also they gave the length of the copper wire. By using the current, area, length as well as the number of charge carriers, we are going to find the answer for the time. Okay, now I'm going to write the given. The current I is equal to 285 ampere. The cross-sectional area A is equal to 0.17 centimeter square. So here I'm going to convert in terms of meter square. So 1 centimeter square, which is equal to 10 to the power of minus 4 meter square. By that we can cancel this centimeter square with centimeter square. So we will get the answer of the area in terms of meter square. So 0.17 multiplied 10 power minus 4 meters square. And the length of the copper wire is mentioned as 0.43 meter. And finally, they give the number of charge carriers n, small n, which is equal to 8.49 multiplied 10 power plus 28 per cubic meter. So now we are going to calculate the time. So for that, I'm going to use the basic equation for the speed. As we already studied in physics 1, the speed which is equal to the distance divided by time. So from that equation, I'm going to start. So as we already know the equation for the speed v, which is equal to the distance divided by time, and here the speed refers to the speed of the electron. So for that we have to modify this speed in terms of v suffix d, which is a drift speed. So what I'm going to do here itself, I'm going to change the value of the speed v of d. So we should not make v simply because this is the speed of the electron. So we have to mention as drift speed. So drift speed, which is equal to the distance over time. Here the distance refers to the length of the wire, right? So in place of distance, I'm going to use the letter L divided by time, and I have to rearrange this equation in terms of time because we are going to find the answer for the time. So therefore, the time is equal to the length of the wire, which is the distance, divided by the drift speed of an electron. We don't have the information about the drift speed, but I'm going to use the relation between the current density and the drift speed is given by the equation J is equal to NQ multiplied by the drift speed, where N is the number of charge carriers, Q is the charge value 1.6 multiplied 10 power minus 19. Because this is the electron, I'm going to take only the magnitude of the value, and the drift speed is Vd. So I'm going to rearrange this equation in terms of drift speed. Therefore, drift speed, which is equal to the current density divided by N multiplied by Q. Now I'm going to take this equation and substitute here. If you substitute this equation in the time equation, the time equation is modified as T, which is equal to L over J over N multiplied by Q. So this NQ will go to the top. So by that, this time equation T is equal to L multiplied by N multiplied by Q divided by the current density J. As we don't have the information about the current density, we already know the current density is given by the equation current over area. Now I'm going to take this current density equation and substitute here. If you substitute, again this time equation is modified as T is equal to length of the wire multiplied by the number of charge carriers multiplied by the charge value divided by the current over area. So this area will go to the top. By that, this equation T is equal to L multiplied by N multiplied by Q multiplied by A divided by I. What is L? L is the length of the wire, N is the number of charge carriers, and Q is the charge value, which is negative of 1.6 multiplied 10 power minus 19. But here we are going to consider only the magnitude. The A is the area, the cross-sectional area of the wire, and I is the current value. So we have all these information. Now I am going to substitute this value in this equation. So if you substitute this equation, T is equal to length of the wire is already mentioned in the question as 0.43 meter multiplied the number of charge carriers also mentioned in the question as 8.49 multiplied 10 power 28, and also the charge value is 1.6. Here I am going to write only the magnitude value. So 1.6 multiplied 10 power minus 19, and the cross-sectional area is already given in the question. As we already convert the centimeter square to meter square, we got the answer for the area is 0.17 multiplied 10 power minus 4 meter square divided by the current. The current value already given in the question as 285 ampere. If you calculate everything, we will get the answer for the time in terms of second as 348.4 second. Actually, this number is a little bit bigger. So what I'm going to do, I plan to convert this second in terms of minutes. By that, we will get a clear picture. So I'm going to convert this second in terms of minutes. So T, which is equal to 348.4 second, in 1 minute 60 second. So we can second. By that we will get the answer for the time in terms of minutes. So if you divide 348.4 with 60, we will get the answer as 5.8 minutes. So this is the answer for the time in terms of minutes, or if you want to give the answer in terms of seconds, you can just leave as it is. So in the question they did not mention anything, but here I just show how to convert the second to minutes. That's it. This is the answer for this question. Thank you.